In this video, you're going to become aware that algorithmic complexity and hardware imposes limits on what can be computed. And you're going to understand what is meant by tractable and intractable problems. Computing-based solutions in the form of algorithms cannot be used to solve all problems. There are three areas to consider: hardware limits, intractable problems, and problems that can't be solved algorithmically. Let's take a look at each in turn. So both hardware and complexity exponential can pose limits on algorithms even if they're technically solvable. A particular problem could simply require more computing memory than is feasible, thus rendering it effectively unsolvable. Or the problem could have what's called an exponential complexity. This means the problem requires an exponential amount of work for it to be done. In this situation, using a faster or more processing hardware will make very little difference at all. There's also the issue of intractable problems. As computer scientists, we're only really interested in algorithms which can solve problems in a reasonable amount of time using a reasonable amount of memory. Tractable problems is any problem which is solvable in polynomial time or better. In other words, the algorithm to solve this problem will run quickly enough for it to be practical and useful. Intractable problems is any problem that cannot be solved in a polynomial time or better. Note, this doesn't mean they can't be solved by an algorithm, just that as soon as the input side increases to anything other than a very small number, it becomes impractical for a computer to solve it in a sensible time frame. Now, it is possible to use heuristics to make intractable problems useful by sacrificing an optimal answer for one that we consider good enough to be useful. There are also limits on algorithms in that there are some problems that simply can't be solved. A problem is computable if an algorithm exists which solves it. In 1920, David Hilbert proposed any problem defined properly could be solved by writing an appropriate algorithm. Well, we've since managed to prove that this is false, and this was done by the work of Alan Turing and the halting problem, which is the subject of the next video. There are a whole number of problems which computers simply can't do easily or at all, as well as humans. Any problem which is broad or poorly defined presents problems, even sophisticated current AI. Problems that call for subjective evaluations are also very tricky to solve by computer. There are also problems that exist which simply will never be able to be solved by computers. Here's three examples which you can have a look at yourself on the internet, and it doesn't matter the level of computing hardware, the speed, or what algorithm is written, these problems could never be solved. In the next video, we will take a look at the halting problem.